Okay, let's just take a look at this whole question from scratch again. We need to take that number and write it to one significant figure. So which is the most significant of those numbers?
2.
Alright, and we're going to look at the
7.
Alright, so does it stay 2 or does it become 3?
Become 3.
So we just write that.
No. 0,003.
Yeah, okay, so we got to keep it as the decimal.
Yeah.
Okay, so it's 0,003. Alright, then moving to the 3,400. Which is the most significant number there?
3.
Okay, so we look at the 4. The number immediately to the right, so does it stay 3?
Yeah, it stays 3.
Okay. Then we move to the number below the line. Which is the most significant number there?
The 9.
Alright, and we look at the number immediately to the right, so what happens there?
Become 10.
Alright, and then lastly, which is the most significant number?
2.
Right, and we will look at the number immediately to the right, so it stays 2.
Yeah.
Or 20.
20.
Alright, and then you can now calculate those two for me so long, because that's part B. We're now moving on to part B.
Okay.
Oh, okay, no, sorry, I'm just noticing they say estimate the value of B.
Oh.
Okay, so what do you think 0,003 times by 3,000 is going to be?
9.
9.
Yeah.
Alright, and 10 plus 20?
That'll be 30.
Squared.
Okay. 900.
Alright, and 9 divided by 900?
0,01.
Are you working this out with your calculator?
Yeah.
Yeah, no, they said estimate.
Oh.
Okay, so you're not supposed to use a calculator. But okay, I don't really see how you are supposed to estimate an answer without using a calculator. You know, without looking like at least you've used a calculator, because it does seem right.
Yeah.
Okay, so yeah, anyway.
But it's 0,01, eh?
Is it 0,01?
Yeah.
Okay. But still, you know, it's supposed to be an estimate, but I don't know how you can estimate it without being very close to correct anyway. So, alright, doesn't really matter. Okay, so you happy with that?
Yeah.
Alright, then let's move to the next question. Okay, number 7, simultaneous equations. Right, do you know how to do simultaneous equations?
Yeah, I do.
Okay, so take me through it.
Okay, you have to get the 2x alone. So
yeah, okay, remember that's the technique of substitution that you're now thinking of.
Huh?
You are thinking of the technique of substitution.
Oh.
There are two ways of getting simultaneous equations. One is substitution, where you get the x or the y alone, and you substitute it into the other equation.
Okay.
Or alternatively, you can make use of the elimination technique.
Oh.
Alright, which is going to work in this case because you've got x to the power of 1, x to the power of 1, y to the power of 1, and y to the power of 1. Okay, elimination works if you have that. Substitution works all the ways, but elimination only works if you have the same x to the power of 1 and y to the power of 1, one of each in each equation.
Oh.
Okay, it doesn't really matter. What you need to remember actually is before you proceed, get rid of the fractions.
Okay.
So how are we going to get rid of that fraction there and there?
You can, I don't know.
Well, let's just multiply right through by 2.
Okay.
So the first equation becomes 4x.
Okay.
The second term basically just becomes y. Do you agree?
Yeah.
Because half times 2 is 1.
Okay.
And the 1 on the right hand side becomes 2.
Okay.
Are you happy?
Yeah.
Alright, then the second equation becomes
12x.
12x.
And then 6y.
No, no.
Okay.
Remember, you're multiplying by 2, which means those 2's cancel.
Oh.
So all that remains is minus 3y.
Okay.
Are you happy? You
Yeah.
understand what I'm saying?
Yeah.
That's the whole idea, is to get rid of the fraction,
Oh, okay.
so that the denominator can cancel out.
Okay.
And then the right hand side.
42.
Okay. See, now it's a lot easier to work with,
Yeah.
because you don't have fractions anymore.
Okay.
So now, do you want to do the elimination or the substitution technique?
I think the elimination one is a bit better.
Okay, so all we have to do is to multiply the top expression by 3. Okay, because we have a minus 3y there already and a plus 1y. So if we multiply the top expression by 3, it will become 12x plus 3y is equal to 6. Do you agree?
Okay.
Okay, the second expression is 12x minus 3y is equal to 42.
Okay.
Alright, now all we have to do is to add them all up. So that will give us 24x, and the y's fall away. That's why we multiply it with 3, so that now the y's become 0.
Oh, okay.
And this becomes 48.
Okay.
So divide both sides by 24, and x will then be equal to
2.
Okay, and then you substitute that 2, say, into there.
Okay.
So it becomes 8
8.
plus y is equal to 2.
Okay.
So y is equal to?
Minus 6.
Yep. That's it.
Oh. Oh, that was easier.
Well, look, like I said, it's only valid if you have the same exponents, for x and y.
Oh, okay.
And only, you can't have any squared terms like x squared or y squared or, something like that, because then elimination won't work.
Oh, okay.
But if you have x to the power of 1 and y to the power of 1 in both of your equations, the technique of elimination sometimes just works easier. But substitution works always,
Oh, okay.
but it might take longer.
Oh.
Okay.
Can I print this?